You may have heard that natural gas is the cheapest way to heat your house, and in many cases that's true. However, heat pump technology can offer you a large reduction in your emissions, and if you get creative, actually beat the economics of natural gas. Welcome back. I assume at this point in time you've had a chance to review the Intro to Heating and Cooling podcast, and you have natural gas access, pipeline natural gas access for your house, which brings you here. So today we're going to talk about how heat pump technology can certainly improve your emissions. Great for the world, and it's a little more challenging on your wallet, but we've got some creative ideas to help you there as well. Before we jump in, just want a reminder, plan ahead. Again, you don't want your air conditioner to fail during the summer, your furnace to fail in the winter, you're in an emergency situation, you're not going to have a lot of options, and you're going to pay a lot more money. So do your due diligence. We'll talk about that at the end, getting some options understood. We're going to talk about a couple different kind of heat pumps today. The one that you may be more familiar with is on your right. It's an air-sourced heat pump. Looks just like your air conditioner, because it is. In the summer, it pumps heat out of the house into a hot environment. But in the winter, it has a thing called a reversing valve, so it can reverse its process, and it can drive heat from a cold environment outside into the house, just like magic. But it works. On the other side, you can see what's called a ground-sourced heat pump. It has an additional piece of equipment, and it's basically a big, long heat exchanger, a pipe with a liquid in it that goes down below the earth and circulates the liquid there, gets to the temperature down below the earth, stays about 53 degrees, and there you're driving heat out of the house in the summer into a much cooler environment, and you're extracting heat out of the earth in the winter, and again, a much warmer environment than the outside air. With heat pump technology, there's a thing called auxiliary or emergency heat. And with a standard air-sourced heat pump, you have to have it, because once the temperature outside goes down, the efficiency decreases, and you'll get to the point where it costs more money and it won't keep up and heat your house. So that'll kick in. And there you've got a choice between your natural gas furnace to kick in or more expensive resistance heating. There's also a newer technology coming out called a cold climate heat pump. And there it's much more efficient and it's much more expensive, but it can continue to pump heat into the house when it gets down to even 15 degrees below zero. It gets more expensive down there. And in that case, you don't need the auxiliary heat. But in most cases, they will install what's called an emergency heat. So again, a resistance heater that's very cheap to put in, just in case the heat pump fails, your house doesn't freeze. On the ground source heat pump, you don't need auxiliary heat either. It's always pumping out of 52 degree ambient temperatures from down below. It really doesn't need it, but just in case it fails, they normally install, again, an inexpensive resistance heat backup that when it runs, it's expensive. But in that case, you're not going to need it. Now, when I went to look at all these different alternatives, what to do at my house, friends, and family, I was frustrated that there wasn't any unbiased tools out there to help me analyze the wallet and the world comparison with all these different technologies. You could find some things out there, but they always gave you the answer they wanted. So went out and developed our own model using an MIT mechanical engineer who's worked for GE Power in that industry. And basically, it can take just about any kind of heat pump and any city's weather history and analyze these different technologies for the cost to operate and the impact on the environment, the carbon dioxide emissions. So once you get some different options, you can come book a Zoom meeting and we can run this tool to analyze your specific situation. And if you want to engage your HVAC company in that discussion, happy to do so. Would love to have this technology and this model used more broadly. To develop a do-it-yourself tool, we had to simplify that very complex model so you can do some directional analysis yourself. So what we did was we just took one average household, 3,000 square foot house that's insulated relatively well and has a natural gas and an air conditioner central system that circulates using an air handler, the heat in the winter and the cooling in the summer. We also picked just one city in one of 5 different zones in the United States. So it simplifies things. It's not your exact situation, but it will give you directionally a feel for your impact on your wallet and the world for these different technologies. Before we jump into the tools, there's 2 things you're going to need. One is your electricity price, and hopefully through the solar panel app or solar panel tool, you can determine what your average annual electricity cost is. You're going to also need your natural gas price. That's a little more complicated because it varies throughout the year. We'll give you a link to the Government Energy Information Agency, and it'll get you to the natural gas page, and you click down here on prices, then you click down here residential, and then you can pick your state. And you can look down here, and it'll give you, here's Delaware, it'll give you the last few months, but it'll also here on the right side give you, 25-year history. What you can see, it goes up and down every year. And the reason is that during the winter, natural gas volume is much, much higher. And that's when you're heating, and therefore their delivery cost is much lower. They don't need a high price to make money. And during the summer, it can double. So you can look at this for your state, but understand this is state average. Your local utility may be different. So what you normally want to do is take a look at your bills during the winter season. So December through March, take a look at what your dollar your bill was for natural gas, divide it by whatever units you used, and you'll get your specific cost for natural gas. Okay, now let's look at the tools. We'll go into tools, let's go to the heating and tool comparison. You got to put in your electricity price that you got from the solar episode. You got to choose your fossil fuel type. Natural gas, either in therms or CCF. We'll talk about oil and propane in a different show. And here I choose natural gas in dollars per therm. You come down here, the national average is 1.4. Again, you may be higher and lower each one of these. The electricity source, again, we talked about that in the carbon footprint. The default is natural gas, but you can choose coal or your specific sub-region. And here you got to choose what zone you're in. So if you look at the map below, there's 7 different zones, but we give you a choice between 2, 3, 4, 5, and 6. I'm in the yellow zone 4, and that puts in climate data for cooling and heating season specific to you. And then down here, you've got to put your installation costs. And again, these could vary widely because there's many, many different type of air conditioner, furnaces, heat pumps, and you'll get very different prices from different vendors. So you got to go out, get a few that's specific for you. What I'll do here is just enter some typical stuff. Here, you replace your furnace and air conditioner, the entire system, nominally cost you $15,000 for a 95% efficient furnace and an average air conditioner. If you want to put a furnace and a heat pump in, it'll cost you more. So instead of the air conditioner, you put the heat pump in, a couple thousand more. You may want to go for a cold climate heat pump, and that could cost you a bit more. So we'll put $18,000, so $3,000 more than the base case. And then a heat pump, get rid of your natural gas, a heat pump with resistance backup normally costs about the same. You might be able to get it a little bit less than the furnace and air conditioner combined. And then here's a ground source heat pump. Oh, looks expensive. It's actually more expensive than that. It's more like 40 to 50,000, but the IRA still gives you a 30% tax credit, so your net investment will be lower than that. But that big heat exchanger you put down into the ground is pretty expensive. Let's see what the results are for Zone 4 with average electricity price, average natural gas price. You can see here's the installation costs we just entered. Here's the operating costs, both the heating and the cooling for the entire year. And here's the savings. You can see the furnace heat pump saves a little bit of money, doesn't quite fully return that investment over the life of the system, but you reduce your CO2 emissions by 20%. You put in a cold climate heat pump, it saves you more money, both in the cooling and the heating season. It's more efficient. You can return that. You're getting close to returning that in the life of the equipment, but you get a 35% reduction in your carbon dioxide emissions. The heat pump with the resistance costs you actually more to operate. So it's a negative return, but you may get a deal there where it's actually cheaper than the furnace and air conditioner. Here I said it was $100 more, so it's a negative return, and you get a 28% reduction in your carbon emissions. Finally, ground source heat pump saves you the most money, almost pays it off during the life of the unit, but you get a 52% reduction on your CO2 emissions. Let's take a look at a couple different zones. Let's go to the warmest zone, Zone 2. You can see that's kind of down in southern Texas and Florida. And what you see here is, you still get, similar operating costs per year, but it's more cooling, less heating than Zone 4. You still save about the same money with the furnace heat pump. The cold climate heat pump saves you even more because it's more efficient in the summer than a normal air conditioner. Your heat pump and resistive backup saves you money because you're down south, you're not operating that resistance heater much at all. And it's quick payback. And then finally down here, the ground source heat pump does save you a lot of money, almost gets the return, but mostly it's helping you cool, not heat. Finally, let's go up and take a look at the cold zone, 6, which you can see is up there, northern New England, New York, and Wisconsin, the Dakotas, etc. And what happens here? You still save a little bit of money each year with the furnace heat pump. Cold climate heat pump actually costs you more because you're down really cold temperatures, where the cold climate heat pump still works, but it's more expensive than natural gas at those temperatures. The resistive heat, it doesn't look good at all because it's cold a lot of the time and you're using that real expensive auxiliary heat. And the ground source heat pump saves you the most, gives you a pretty good return. Let's go back again to the Zone 4 and take a look at an option we can talk about on a Zoom call that gets creative. Again, those returns, and we'll show you a plot a little bit later, they're not great returns. They're probably at or below U.S. Treasury bond. But over here, what we do is we calculate how many added kilowatt hours you put in. By reducing your natural gas or eliminating it, you added kilowatt hours of electricity. Now, these are the approximate number of panels you might have to install above and beyond your normal solar design to produce that electricity. And by doing that, you can get that carbon dioxide down to zero. The calculations get a little complicated because everybody's in a different heating zone, in a different solar zone. Your house may have a different exposure. So this tool doesn't give you the exact calculation on what your returns are, but they get much better. They can approach the returns of the stock market. So you need for that, we really need to book a Zoom call to go through for your particular situation. Let's just take a look at a plot for Zone 4 on what those different technologies will produce. You can see here the ground source heat pump eliminates the most. It's the biggest bubble, the most amount of carbon dioxide. It's got a return approaching U.S. Treasury bonds, and it's still a decent return on the carbon dioxide, but it's a big expense. You can see up here, cold climate heat pump, the air source heat pump with the furnace, the standard model, is, you get money back, but you don't fully return it in the life of the equipment, but it's a pretty good investment on the environment. And finally, an air source heat pump, it's actually a negative return, but it's a pretty good investment for the environment. So here, if you're a practical environmentalist, that's a good move to take. And in our Zoom call, or we might approach it in another show, we'll show you how you can get these bubbles moved over here into some good returns. May not approach 10% like the stock market, but they approach what I consider a no-brainer. Play with the tool, get an idea of the type of financial and emission savings you might get, then engage a couple different HVAC installers. You'll get a wide variety of prices around these different systems because depending on the time of the year, depending if they like heat pumps or geothermal more than the others, they may be getting volume discounts. You'll see a wide variety of prices. So get them from several folks, book a Zoom meeting, and we can talk through those, maybe run some of them on our more sophisticated model based on your individual consumption in your house. And then if you're putting in solar at the same time, we can take a look at what the economics would look like by putting in heat pump technology combined with additional solar to get you basically heating and cooling your house from the sun with zero carbon footprint. I hope you enjoyed the show. Hope to talk to you soon. Thank you for listening to Fade Your Footprint, a show about home decarbonization. Make sure you visit my website, fadeyourfootprint.org, and check out my free tools or book a Zoom session with me to take steps toward reducing your personal carbon emissions.